This is the first question. So let's just do it together. I want you to tell me what they are. So I'm going to go dy dx. So that's the expecting to be x. So, and then we can write a y dash if you want. Or sometimes you go f dash. They're all the same. If this was f of x. Okay? Same thing. Now, tell me, guys, what's the first thing you have to do?
You have to move the power to the front.
Which is 4, and then 2x plus 9 to the power of 1 less 3 times dy dx of the inside, which is, so 2x plus 9, derivative of that is 2.
Okay, yeah.
Okay, so if this was a 5x plus 1, 5x plus 1, what's the derivative of 5x plus 1? 5. Okay, so it's always 1 less per numeral. Okay, and then if it's a constant, we don't care. Why? Because it's actually got x to power 0 here. That's x power 1, isn't it? 0 minus 1 is a negative power, so we don't deal with that. Okay, so let's have a look at that. So let's sort this out. I'm going to tidy it up. So it'll be 8. That's it. We okay with that?
Yeah.
Yep. All right, so next one, hopefully next one, you can tell me what we're doing. Yes?
Yeah.
Okay, so I'm going to go f of x, and let me see, 2x minus 1, 3. So let's do this together. So derivative, what's the notation for the derivative of f of x? It's f dash of x. So tell me, what do we have to, what's the first step? The power goes to the front, isn't it?
Yeah.
So it'll be 2 times what? 3, yeah. X minus 1 to the power of?
2.
2. And what's the derivative of x minus 1?
1.
1. It's always just whatever it's on the coefficient of the x is going to be. Okay? So 1. And I don't really need to do that, but just for visual pleasure, I'll just put that in. So what's this one? 6. Like that. Are we all good?
Yeah.
Okay. So I'm going to challenge you a bit now. Just a little bit. So if I have something like 2, 8x3 minus 1 and 3. Looks a little bit more complicated, but it's not too bad. It's not too bad, I don't think. Yeah. So what will be my first step on this? F dash of x. So the power goes to the front. It'll be 2 times, by the way, this little dot is times. Dot, what's the power? 3. And 8x cubed minus, it's still all the same, but only thing it's going to be different is the power, isn't it? 2 times, what's the derivative of 8x cubed minus 1? If it was 3x squared plus 1, what would be y dash here? Still same operation here. The power goes to the front, so it'll be 3 times 2 x power 1, isn't it? 2 minus 1. So 1, I'm not going to put that in, and the constant disappears. It'll be 6x, wouldn't it? So here, so therefore, y dash will be, you're going to the front, so 8 times what? 3 x to the power of 2, 1 less. And I'm not going to worry about the constant. So what's the tidied up solution here? 24x power 2.
Yeah.
So that will be 24x squared. We we okay with that?
Yeah.
So let's tighten up a little bit. We need to put all the numbers in the front. Yeah? So somebody calculate this for me. So this is a 6. 6 times 24, isn't it? 6 times 24, which is
144.
144x squared. I'm going to put it in the square here. And then 8x cubed minus 1 squared. And I'm just going to leave it like that.
Yeah.
You don't have to expand. Let's see. Y equals 8. 2x squared plus 3 minus 2. It's got negative power. Interesting. But the principle, the way you're doing things is the same. So what's this going to be? Y dash equals, right? So 8 times, I'm going to bring the power to the front, which is, what's the power at the moment?
-2.
Yep, -2. And it's a good idea to put in the brackets if it's negative. And I'm going to put as it is right now, -2 minus 1. Is that right? So don't do it in your head. Just write it like that, just to be, you don't make a silly mistake there. Now, times derivative of 2x squared plus 3. What's the derivative of differentiate of 2x squared plus 3? It'll be, what's the derivative of, so this is really, what we are looking at is this,
4x.
right? So that will be 4x. That's it, isn't it?
Yeah.
Okay, so I'm going to go y dash equals, all right, I'm going to tie this one up. What's double of 8?
16.
16 minus 16, 2x squared plus 3. Now that will become minus 3, wouldn't it?
Yeah.
And what happens here? I'm going to times by 4x. And I'm going to bring this to the front, because I want the whole number to be in the front of the expression. So minus 16 times 4. What's minus 16 times 4?
64.
64. And then x goes there. 2x squared plus 3 minus 3. I'm going to leave it like that because the question had a negative power. So I'm just going to leave it like that.
Okay.
But if you want to, you don't like negative, you could go that's exactly the same. Is that okay? Because that means fraction, not the negative value, fraction. Are we okay with this?
Yeah.
Yep. Okay, y equals, that's an interesting one. Alright, have a go. Okay, so let's do y dash equals, now power goes to the front, minus 3 over 4. 4x squared minus 2, minus 3 over 4 minus 1. I'm just going to put that in there. Don't do it in your head. And then what's the derivative of 4x squared minus 2? It'll be 8x.
Yep.
8x. Now, I'm going to bring this 8x to the front. And then, what's the minus 3 over 4 minus 1? Minus 7 over 4. Yeah? So, and then I'm going to simplify this to do minus 6x, 4x squared minus 2 minus 7 over 4. We all good?
Yeah.
This? Yep. Excellent. Number 1. Product rule. We'll have 2 expressions that we will have to work with. So, for example, I'm just looking at the question. 6 squared 3 cubed minus 2x plus 5. Okay, so you've got 2 terms times together. So I'm going to have to decide which one's going to be my u, which one's going to be my v. Okay, so the first one is my u, second one is my v. Okay, so I want you to do sort of like this. U equals x squared v equals x cubed minus 2x plus 5. Okay, and then I'm going to do one at a time. What's x derivative of x squared?
2x.
Yeah, 2x. Say it with a sort of confidence. Okay?
Okay.
Alright, what's a v dash? V dash will be
3x squared minus 2.
and then we get rid of the constant. Yeah? Now this is the important part. Okay? This is the important part. Do this first. Always. I mean, with the product doesn't really matter which one comes first, plus, because it's a plus. But quotient, you have to be careful with which one comes first because it's a negative. But the just straight line, bold line is the first one. The dotted line is the second. So now I'm going to go y dash equals, I'm going to go this first. I'm going to times this together. So 2x plus 5 plus x squared. Now if it's a more than one term, always put in a bracket. Okay? And then we're going to expand this because we want to simplify it. So there, we times it. So it'll be 2x to the power 4 minus 4x squared plus 10x. And then plus 3x to the power 4 minus 2x squared. So then I have to collect the like terms. And then that's just by itself. So it'll be 5x to the power 4 minus 6x squared plus 10x. Did you get that? Real good?
Yeah.
Yep, excellent. Number 2, here we go. Let me see. Y equals 7x cubed minus 1 and 2x squared plus 6x plus 5. Alright, have a go at that. And then we do 42. So for 70, 100 and 68. Is that what you got? Number 2, is it?
Yeah.
Okay, number 3. Yeah. Okay, so y equals x squared plus 5x is 4x minus 11 to the power of 6. So you decide which one's going to be your u, which one's going to be your v. So u, first one is my u, second one is my v, and then u dash, v dash, make sure you put it in the brackets. Oops, that's not the one. want you to stop for a while. Up to here. When you're done up to here, I want you to stop. Because I don't want you to expand anything on this side. Okay? Now, don't try to expand this. You're wasting your time. But instead, we can see that this is our common factors, right? What will be my common factors here? 4x minus 11 to the power of 5,
Yeah.
isn't it? Because you can't do 6 because this one doesn't have one more. So the maximum you can have as common factor will be 4x minus 11 to the power of 5. Is that right? Yes, yes. So you got 4x minus 11 to the 5. Okay, I'm going to take that out. What do you got left here? I've got 2x plus 5 and one more of this. Correct? Yes, one more of that. And here I've got 24 and x squared plus 5x, and I have nothing because everything is gone to the front. I've got nothing left except for 1, but which I'm not going to do anything. And then we sort this out. But it's easier than expanding that, isn't it? So when you comes to here, do not expand but factorize. Okay? So then 4x. So let's expand this one. What would that be if I expand this one? Let's do it together. 8x minus, what's 2x minus 11? 22x plus 20x. It's okay. You're not doing anything wrong. Say it a little bit louder. What's it? 5 times 11 minus
55.
55. And this one plus 24x squared plus what's 24 times 5? 120. So, okay, I've got lots of because I forgot about that, and that's now it's okay, it's okay. So let's put it in. 8 plus 24, 32x squared, and this will be minus 2x plus 120, so plus 118x, is that right?
Yeah.
And then minus 55. We okay with that? Let me change this one. And I'm not going to do anything about it. Just going to leave it. You can factorize it, but I don't know. I don't think it's going to be factorized nicely, and I'm not going to spend the time on that. So that's it. We're done. Okay, quotient rule. Let's start with basic. Okay, the first step will be deciding what is u, what is v. U normally is on the top, the denominator, numerator. V is the denominator. So u equals x, v equals x plus 4. U dash is, what is u dash? Yes, 1. What's a v dash? Say it. 1. Okay? And then I will go that first, second. So y dash. Now it's a quotient, so if it's a fraction, stay in a fraction. Remember that? X plus 4 squared. Because it's a v squared, the formula is right there. So this 1 times that is just x plus 4. Now, second one's negative. So x times 1 is x, so it's going to be like that. Okay? And it cancels out. And I'm just going to leave it like that. 2, had enough. Okay, next one. Y equals x squared plus 5 have a go at that. So you first decide what is u, what is a v. U is what's on the top. Oops. So numerator and denominator is my v. And then I'm going to go y dash, or you can do dy dx. That's what now. 6x squared. Make sure the whole thing squared, not just x. And then go this one first. Minus 6. Take the 6 out. So your final answer will be there. So last one for quotient before we go into the finding a equation of a tangent and normal. Minus 2x minus 3 all over x squared minus 2. Alright, go. So my u, my v, so u dash, v dash, minus so expand this one. Minus okay, let's see if I can get this correct. So 2x squared plus 2x plus 4. I mean, I don't really need to like factorize, but I felt like I need to do that. Alright, put it on. Okay, so now what we've done so far is all about this. Okay, we're going to find the equation of the tangent to the a given curve, which is the and this one is y equals x power 5. That's the curve at the given point, which is, I think it's 1 and 1. Yes, 1 and 1. So if this was given, and we have to find tangent. So this is like probably roughly 1, 2, 3, 4. It's a 4, 5. So it's the one of these gonna be something like up like this. You know the cubic is like this, right? Yeah, and it goes up when it's a positive.
Yeah.
So it's a power of 5, so it's going to be something like that. Is it that's 1, 1, 2, 3 x, y equals 3, 4 something. Is that right? Something like that. That's still x cubed, isn't it? Yeah, what am I talking? 1, 2, 3, 4, 5. Yes. So that's still cubic because there's a 3 x-intercepts. Okay? Plus 0. But this one is, interesting. I think it is still very much like this. But it's going to be very flattening because it's plus 0. Okay? Something like that. Okay, so anyway, we're going to find the tangent. Tangent is what? It's touching the curve only once, at one point. Okay, so we're going to find the equation on that. What we need first is the gradient. Okay, we need a gradient, which is a little m, for tangent of gradient, which is dy dx. Okay, d is like a change. So change of y's, change of x's. That's your gradient, really, isn't it? If you think about rise of run, it's a change of the y's, the rise, change of the x's, the run. So that's what we need, and we need a point. P-O-I-N-T, point on the curve, which is what we got, 1 and 1. Okay, so all I have to do really is to find the gradient. Okay, so dy dx, that's all I have to find. What's the dy dx here? If y equals x to the power 5, what's dy dx?
4x.
No?
I mean 5x
5x
to the power 4.
4 at 1 and 1, which is just x equals 1, isn't it? Yeah, all we need is just x value. So when x equals 1, so the gradient of tangent at 1 and 1 is 5. Okay, I'm going to use gradient point formula. Gradient point formula, you could have y minus y1 equals mx minus x1. Or you could use this. Do you remember this? You can use this one or this one, doesn't really matter. So if I used this one, okay, so I'll go 5x plus b, and at 1 and 1 I can find the b, right? So if I substitute 1, 5, 1 plus b, 1 equals 5 plus b, what's the b? You minus 5 on both sides, what do you get? Minus 5 minus 5? Negative 4. Because of minus 5, that's 0, negative 4. So therefore my equation is 5x negative 4. Or if I use this one, let's see if it's the same. At 1 and 1. So y minus 1, that's my x1, that's y1, equals 5, because gradient was 5, x minus 1. Isn't it?
Yep.
So I'm going to expand this one, 5x minus 5, and I'm going to make the y the subject, 5x. I get plus 1 plus 1. It'll be, if I do plus 1 here, plus 1 here, what do you get?
You get 0 and negative 4.
Yeah, negative 4. Can you see the same?
Yeah.
So I personally like this quicker, but you know, a lot of people use this, so it's up to you what you do. So that's what you do. So or this or that. Are we okay with this?
Yeah.
Yeah. So I'm going to change this one. Let's see. Y equals x cubed minus 5x at x equals 2. This time I'm just giving you x value only. So it'll be okay for gradient, but when you have to use the point gradient formula, you need to y value, don't you? So it's a good idea to find y value before you start. So I would say, number one, find y value first, and then find the gradient, and then a point of curve, which is, we got 2, but we don't know what y is. Go. Turn it off. Did you turn it on?
Yeah.
So that's what happens. Are we all good? Yes or no?
Okay.
Yeah. Number 3. Now this time we're going to go with normal. Okay? Equation of normal. You stop. Okay, turn it on.
It's on.
Yep. So this time we're going to find the equation of the normal. So this is the find the gradient of the normal to the given curve at the given point. But I'm just going to say just find the equation instead of just finding gradient. Okay. So same thing as before, like the tangent, very, very similar. Only thing is different is the gradient with tangent and normal. When the product of that is -1 when you times it. So for example, if I go y dash, which is dy dx, isn't it? Which is m tangent. So you have to find the gradient of tangent first. Okay, so which will be, what's the derivative of x minus x squared?
1 minus
2x. Yes? And then you put x in there. So what's that going to be? X equals 1, right? So you put 1 in there, what do you get? Which is 1 minus 2. What's 1 minus 2? -1. Okay? So your gradient for tangent is -1. Therefore, what is your gradient of normal? Meaning, negative of reciprocal, okay, of the tangent, gradient of tangent. So what's the reciprocal of -1?
Is it
So over 1.
1 of minus 1
Okay.
over 1?
If a reciprocal of 2 is half, reciprocal of 3 is,
1 over 3. So
what's the reciprocal of 1 over 3?
1 over 3.
Yeah, 3. Is that okay?
So it
So
should be
reciprocal
minus
of that, it just
well, minus 1 over
over
1.
1, which is just -1. But it's a negative of that. So your reciprocal of negative of reciprocal of this is 1. So I'm saying, what's a reciprocal of negative reciprocal of 2? What's a negative reciprocal of 2? You do reciprocal first, which is half, isn't it?
Yeah.
Negative.
Negative 1 over 2.
So what happens is when you times this together, you're aiming for -1.
Okay.
Okay? You get 1 when you times that number with that reciprocal of that number. So for example, A. What's the reciprocal of A? 1 over A.
Yeah.
It's going to be 1. Okay? So always the number times by that reciprocal of that number is always going to be 1 because it cancels out. But it's a reciprocal of that number, but it's a negative reciprocal. Okay? So it's going to be positive 1.
Yeah.
Are we okay with that? So we got that at 1, and we need to find the y value, don't we? Okay? Because we don't want just x, we need a point. So let's find it. When x equals 1, what's y value going to be? 1 minus 1, isn't it? Which is 0. So you got gradient of normal, you got the point. Exactly same concept. So I'm going to use y equals mx plus b. Okay? So y was 0, m was 1, x is 1 plus b. So what's b?
B is negative.
Yeah, negative 1. So what's your equation then? Y equals 1, which is x, minus 1. That's your equation of the normal.
Yeah.
We're all with that. The only thing different was exactly the same as before, but when it comes to finding a gradient of tangent, you've got to do negative reciprocal. You flip, but you put the negative in there. Okay? So if, for example, if this was negative 5, what would be the gradient of normal? You flip and negative. So what would that be? If you flip, what would that be? 1 over 5. If you flip the 5, it would be 1 over 5. That's a reciprocal of 5. But you're putting negative there. So it'll be negative 1 over 5. Does that make sense?
Yeah.
Yeah? Alright, this one, I want you to do it by yourself and see what happens. Y equals x cubed plus x plus 5 at x equals 0. Okay? I want you to find the equation of normal. Let's find the y value. I'm going to find my y value first. Okay? So when x equals 0, y equals 5, isn't it? 0, 0 plus. So my point will be 0 and 5.
Yeah.
Okay? So that's my point. Now, dy dx, which is my, you always have to find gradient of tangent first. So dy dx will be 3x squared plus 1, wouldn't it?
Yeah.
But then I have to go with when x equals 0. So that would be just 1, wouldn't it?
Yeah.
Because that would be 0, wouldn't it?
Wait, hold on. So, what's the second step?
Second step, well, you did a derivative of x cubed plus x plus 5, right? Which is 3x squared plus 1. Yes? Dy dx will be 3x squared plus 1? Yes or no?
So, 3x plus 1.
No, 3x squared plus 1.
Yeah, 3x squared plus 1.
Yeah, because that will be gone.
And then what does this do?
And then x is 0,
Yeah.
so whole thing's going to be 0. So your
Isn't it 1?
Yeah, gradient is 1. So what is your, therefore, this is your tangent, right? What is your normal gradient? Reciprocal, negative reciprocal. What's a, if you flip 1, it would be just still 1, wouldn't it?
If
So your gradient of normal will be minus 1.
wait, what?
Yes, question?
So mx plus b would be y equals mx plus b would be 5 equals
No,
1.
no, you're going way too fast. So do you understand this?
No.
So dy dx, are you okay with dy
Yes,
dx is
yes.
3x squared plus 1? And I'm substituting x into 0
Yeah,
into
yeah,
here.
I've
So
done that. But what is m?
n is the gradient of normal. This is a gradient of a tangent, capital T. Gradient of normal is
So it's
capital
flipped
N.
around?
Yeah, so it's going to be negative flipped around. So if you flip 1 around, it's just 1. Is that right? Because it's 1 over 1, which is just 1. But you have to put negative there.
Why
So-
do we have to do the normal?
Yeah, when you do the normal, when you times this together, you have to have negative 1. So if you don't want to think about the flipping, okay, you can just do it. This was 1, right? What 1 times what will make minus 1?
Minus 1.
That's your gradient.
Well, would that work for every?
Yes, everything. Because
So if it's 5
so m
equals
tangent
5.
times n normal is always going to be negative 1. Always. So
Then it would always just be negative 1.
yeah, but you have to find mn.
Yeah,
Not
but
the
if,
negative
if,
1.
if the gradient of the tangent is 6,
Yes.
then you times it by negative.
6 times what makes negative 1? So 6 times what will make negative 1? That is your,
Would that be the
gradient of-
reciprocal?
yeah, it'll be negative reciprocal. You always put the negative and reciprocal.
Okay.
So if it was a minus 7, what would that be? Minus 1. This one has to be positive, wouldn't it? Because the minus is already there.
So
Well,
it'd be
all you have
1
to
over
do-
7.
Correct. That's all that is
Okay.
for normal.
Yeah.
Are we okay with that?
Okay.
Are you alright with this?
Yeah.
Okay, good. So then y equals, m is minus 1, isn't it? So I'm not going to write a minus 1. I'm just going to go minus x plus b, correct?
But isn't x 0?
No, we use a 0 to find the y value.
Oh, so we're finding x, we're not finding.
No, we're trying to find the b now, y-intercept. Because we got the gradient, right? We got the point. Now we can find the equation of the normal. Equation of normal is like this. If something has something, I know this is the cubic, but if say it was parabola, right? Tangent is like this, just touching right there, right? But normal is like this, right angle. So this is your tangent equation, that's your normal. Okay?
Yeah.
So this is what we're looking for. That's why we need to find gradient of a tangent first, and then we do negative reciprocal to find equation of the normal. Okay with this? So we got this at 0 and 5. So I'm going to use this to find the b. Okay? So b will 5 equals 0 plus b. Is that right? So b is 5.
Yeah.
So what is your equation of the normal? Y equals minus x. What's b?
Negative 5?
No.
Oh no, it's just 5.
Yeah. So plus 5.
Okay.
Are you getting this?
Yeah.
Okay. I mean, the more you do it, the better you will be.
I mean, that's why I suggested isn't x 0, right?
Mm.
Isn't that how you do it? You just
Yeah. X equals 0 to put it in to find the b. Sorry, I didn't understand what you meant.
Okay.
Yeah. Are we okay with this?
Yeah.
So that's why you need a point, you need gradient to find the equation. Can you see that?
Yeah.
Yeah. So this is a gradient and y-intercept formula, whereas the gradient and point formula is this. Do you remember this formula?
Yeah.
This is the gradient and point formula. This is the gradient and y-intercept formula.
Okay.
But otherwise it works. Are we okay with this?
Yeah.
All right.